welcome to another episode of Rustacean Station. I'm your host, Alan Wyma. Today I'm with these two folks. We have Stu Hood and Eric Arellano.
Thank you.
And these folks are maintainers of Pants Build, which is I'm not sure how you call this, like a build system for different languages using Docker, Python. You don't use Rust yet. Yeah. So why don't you guys give the better introduction, because it's very interesting. Why don't you guys take it over on your side so I don't say anything wrong based on my understanding so far?
Yeah, Pants is definitely a build system, and that's sort of the legacy that we come from, particularly building large code bases like monorepos at larger companies where people have a ton of code in one repository, possibly in multiple languages. Over time, we've generalized to much smaller languages or smaller repositories. And yeah, we support building a few different languages. You mentioned the Docker support. We also, as of recently, gained support for sort of orchestrating CI, such that if you want to run a bunch of different Docker builds in parallel, we can organize that for you as well. So build system, sometimes people would say, build orchestrator because they want to put a broader spin on it.
Yeah, so you have Python, Go, Java, Scala. How do you choose which ones you want to use? I mean, is it just based off of people who are kind of asking for support, or because this is all sponsored by your company, right?
So Pants is an open source project, and it's an open source sort of first ecosystem. We definitely have a sponsoring company as well. Eric and I both work at Toolchain Labs. We focus on what the community is coming and asking for. But at least the last 4 or 5 languages that have been added by community members. So at this point, there's relatively little of us sort of deciding that we should add a language, and as much the ecosystem coming along and adding it for us.
Yeah, and one of the main things when we've been adding new languages that we think about is what is the ecosystem like right now and how can we add value to it? Each ecosystem is a lot different. The Python, for example, amazing language, one of my favorites. Also, because the ecosystem is older, has some weird things that are a little bit harder to work with, unlike Rust that was able to learn from all these other languages and from the start have awesome tooling. Go is another language that also has really good tooling, and we decided to add a couple months ago support for. So for Python, for example, our support looks a lot more comprehensive, where still building off of the tools that people use in Python. But because there's so much diversity, it's a lot of allowing people to pick and choose, for example, which linters they want to use. Whereas in Go, there's a lot more standardization. And we focus a lot on building off of what the standard library is already doing. So if we think about Rust, for example, when we want to add Rust support, our integration would be very built on top of Cargo and the great work that's already there, and Clippy and Cargo format, that we are adding unique value on top of what you already get in this great ecosystem.
This is called Pants 2. Does that mean there was a Pants version 1?
Yeah, and that's a really good eye. That's an important point to make.
Yeah, because it's the first thing it says. It says Pants 2 rather than just say Pants build system or Pants itself.
Yes, I'm glad we highlighted that. Yeah, I mean, and the reason for that is that Pants is an older project. It's been around for about a decade almost, and started at Twitter, was open sourced in about 2010, and which makes it much older than a decade. Wow, time flies. But Pants 2 is only 2 years old on October 27th, and it was the version of Pants that actually began using Rust in the core. And so when we made that major version bump, a large portion of the code base was rewritten. Plugin APIs were all changed. Folks are pretty happy with our new plugin APIs, but they are very different from our old ones. And so it's this Python extension API atop a Rust core implemented with a lot of Rust crates from the ecosystem. And so, yeah, Pants 2 is a very different system and one that we're pretty happy with.
Yeah, so what motivated Pants 2 is we had a lot of feedback from 10 years with Pants 1 and realized that Pants 1 was really built to serve a couple companies' needs. It was designed for Twitter and Foursquare and a couple of the early contributors, and it wasn't keeping up with what the everyday problems are that organizations are facing right now. And we wanted to design Pants with all of the history and lessons we learned to meet the everyday organization. That our hypothesis with the project is that about 90% of organizations are kind of doing custom build tooling, that they might be using some bash scripts, maybe some Python scripts or some make files. And it kind of works. It gets the job done, but there's a lot better experience out there that they can have. Stu and I, before we both worked at Toolchain, we were on the developer productivity team at Twitter, where we had an entire team of, I think it was like 10 engineers whose full-time job is to improve the developer experience of people at the organization. Most people don't work or are on teams at an organization like Twitter. That most startups, for example, don't have the resources for that many people focus on developer productivity. And that's our whole goal with Pants, so we can give you that great experience without needing to have this entire team. We can replace that 90% of bash scripts and make files with something that's a lot more intuitive and more joyful to use.
Now, Pants was started because of a issue with current build system. And usually a lot of tools are started like that. Like Git was started because of they were going to get kicked off of their SCM, right?
Right.
I'm guessing Pants has a similar history, right?
Yeah, the history of Pants is connected to monorepos again. A lot of folks who came out of Google about, I guess, 12, 15 years ago now, were in love with the ecosystem that they had at Google, where they used a monorepo, they built everything from source, and because of good tooling, that was fast, right? They essentially didn't have to publish versions of their dependencies in order to make edits to them. Everything sort of continuously integration tested top to bottom. So this monorepo pattern that's sort of come in vogue in the last 15 years, it spawned Bazel, which I think was open source something like 6 or 8 years ago, not precisely sure. But yeah, Pants was created in order to bring good tooling for monorepos into open source. And after Pants was open sourced, Bazel and Buck, which are Google and Facebook's respective monorepo build tools, have sort of come to the fore. And then the JavaScript ecosystem recently, there's been a huge boom in monorepo build tools. There's a lot of sort of development there that sort of makes your head spin. But things like, Lerna and a bunch of others that I'm not going to be able to name. So yeah, that essentially trying to use a single project tool to build thousands, literally, of projects from source in order to integration test them. It's just not going to be able to reuse as much work across that build. It's not going to give you introspection, just sort of say like, what are the dependent files of some file that I've edited because I quickly need to figure out what needs to build in CI. So yeah, good tooling for monorepos is our origin. And over time, we've kept that heritage. And as I said, sort of just tried to scale down to smaller projects to give people a good on-ramp from, oh no, I have 10 projects in my repository and that 11th is the one that's going to break the camel's back and mean my CI gets too slow. Yeah, so our goal is to keep things fast and happy in larger repositories.
Now, what's the slowest part of typical monorepos?
When you have cold builds and suddenly, somebody has made a change to a core library somewhere in your repository and it's all the way down at the bottom of your stack, 10 library hops away from where you are, that is going to trigger a lot of recompilation for you. When you incorporate that change, pull that change into your branch. In a monorepo, because you're not pinned to versions, you would have to build that from source if you didn't have very, very good caching. And so monorepos need to have very good caching and incrementalism so that as you incorporate changes from other denizens of the monorepo, you continue to hit and don't actually need to build things locally. So that's a critical part of sort of having a good experience is caching and also things like remote execution. So caching allows you to reuse the work of other engineers who have already built the thing that you are building. But remote execution allows you to take advantage of more machines when no other developer has built the thing that you've built. And so those are both tools that are in Pants Build's toolbox.
Yeah, so when Stu is talking about builds, that both means compilation, but it also means all the tasks that you do in between writing your code and deploying to production. So it's things like running tests, running Clippy, running cargo format. With Rust, you already get that fine-grained incremental compilation, but you don't get the straight out of cargo git caching of things like test. So Pants can understand at a really granular level all the dependencies of your projects, that this test file depends on these 5 library files out of 100 that you might have. So if some random other file changes, naively, you would have to rerun all your tests because you don't have information on the system, and it's the conservative, safe thing to do. But with fine-grained information, Pants can know, okay, these 5 files changed, so now you need to rerun 10 out of 50 of your tests, and we can use the cache for all of these other ones. Same with running things like Clippy and cargo format. And then you can also do what Stu is saying with remote execution. You can run those tests in a very fine-grained way that you might have 100 test files, and if you have 100 remote workers in the cloud, you have perfect currency that each test file can run at the same time in parallel.
So when we're talking about monorepos, right, I think it's good to relate on a definition. My understanding of what a monorepo is different projects or different kind of self-contained pieces of works or applications, however you want to call that, into one repository, which I think Facebook is very famous for. I think Google does the same thing. Am I correct?
Yes.
Okay.
Yeah.
And this style is very popular outside of these places because for me, I really prefer to have separate, but I understand that it's good to have the two together. And then maybe sometimes I add Git submodules in there.
Intuitively, you would think that a Polyrepo is a lot simpler and the best way to go, that you get to keep things small. Each team gets to do things how they want. And it turns out that a lot of engineering organizations have found that's deceptive, that there's actually a lot of benefits come from using a monorepo and a ton of complexity that you get from keeping things separate. One of the biggest motivations for using a monorepo is this phrase people call dependency hell, which is dealing with all the versions of your projects when they depend on things. So if you have, for example, a couple helper repositories or libraries that you depend on with 5 different projects, you now have to come up with a version for that helper library and release it to your internal registry or to crates.io. And then all of the other projects that consume it have to say which version they want to use. And the issue becomes when you realize that you're working on your application and you need to make a change to that common library. You now have to go track down where that original library is from and talk to the team and coordinate with them to make your change. Then you have to try to figure out who is everyone who is using this library, somehow figure out, am I breaking these 4 other teams? And if you have a good hope that you're not, then release it, test it, and all the other applications, make sure you didn't break anything. If you did break things, you have to go back and repeat this whole process. Whereas if you are in a monorepo, everything runs on head, like head from Git, that all of your code is checked in at the same point. So in a monorepo, you have that same common helper library, and you can see with tools like Pants Build, everything, you can run this command to see everything that depends on that library and know immediately what teams are involved. And your CI all runs the entire project at the same time, that when you make that change, you can immediately get the feedback, whether from the Rust compiler or from your test suite, whether you just broke everyone. You don't need to come up with a new version because everyone is using that common helper library at the same time.
Now, let me play the devil's advocate, right? So if I'm working only on one specific project, right, everybody knows that if I'm just building a iOS app, I'm using Swift or Objective-C, most likely Swift. Android has their own style. And then my backend it could be anything, right? Because people aren't really using, well, I guess they may use Kotlin, but still. Now, if somebody updates in a Fury a bunch of stuff on the back end and I try to merge stuff in, I may get conflicts if stuff starts diverging, right? I can just imagine that things that I don't understand and don't need to deal with are getting merged together, and then I have problems on my side and I don't know how to fix it, and I could be stuck when I want to get my code in. What about this kind of problem? This is something that may happen, right? I mean, what about this kind of issue where if I only was working with one project, that's one language or whatever, this would never come up?
Yeah. Well, how that tends to happen in a Polyrepo setup is when you bump a version of something, you deal with that cost later on, right? You're able to decouple the cost of bumping your dependency versions and sort of do it at some point in the future. But in larger organizations, that cost is very frequently abused and the result is that things sort of end up on very outdated versions. Things like Dependabot help a lot there. And you sort of get individual commits for all of these bumps. But that's an example of tooling that can sort of help with a problem that sort of monorepos don't have. And one of the advantages, honestly, of both Dependabot and monorepos, where Dependabot is bumping an individual version and giving you a bunch of sort of automated commits, is that you can bisect, right? So in a monorepo, you can always bisect to precisely the change that broke you, because you have commits for every, that hits head. And the worst case in a monorepo is that you get bisect and end up on a third-party dep, because somebody bumped a version of a third party outside of your monorepo, third-party library. And so it's like, oh, well, now the change was introduced somewhere in that version's release. But that's the default case in a polyrepo, right? And any upgrade from outside is likely to be your culprit, and you're not going to be able to bisect directly to the change that introduced your issue.
Yeah, and Alan, you raise a good point that in general, I am the Rust backend team, for example. I don't really want to have to deal with what the front end team is doing and have to run all their tests, for example. And precisely why tools like Pants exist is that they understand the structure and dependencies of all of your code and have that fine-grained caching. So if you are only changing the Rust backend code and that doesn't happen to have a dependency on the front end, then you don't have to run any of their tests or any of their tools. The tool automates, the build system automates that understanding for you of knowing exactly what it is that's changed and what needs to be rerun in CI.
Now, to play it back to the other side, I can imagine that this would actually make things easier to say, okay, I made an update to either the back end or the front end. Now I want to run tests that kind of do a smoke test or whatever you want to call it, integration test between the two. That makes life easier, obviously.
Exactly.
Right?
Yeah, absolutely. And I think the ecosystems have improved quite a bit. Like this is on a 15-year time frame, which is quite old and feeling old right now. The ecosystems have improved a bunch to allow for Git SHA-based versioning. And so Cargo and a bunch of JavaScript ecosystems and Python recently, Go for its entire lifetime, have allowed you to sort of say, I'd like to consume this Git SHA. When monorepos sort of first were coming into vogue, that was less common and people were sort of married to consuming only released versions. But if you have an ecosystem that allows you to build from a Git SHA, that improves things a little bit. Even then, though, if you want to integration test 3 hops away, what you're going to have to do is commit 4 different projects, essentially. A little bump that says, now use this SHA, now use this SHA, now use this SHA. And you've created a linked list that leads back to the code you were actually working on to incorporate a fix in a library. So in a monorepo, that's commit over here, run test over here, and get automatic change detection, right? Like Pants build supports watching the file system and rerunning your tests as things change. So, 4 projects away, 10 projects away, you get that edit and your test immediately reruns. So integration testing can be a lot easier.
Yeah, I'm sure it could be a lot easier, but there's still a lot more stuff besides your code, right? Your database got to be set up, all these other extra things. So integration testing is definitely not fun. And that's just the stuff that's off the top of my head. I can imagine there's so much more. And even like integration testing, you probably want to have some kind of headless browser if you're doing a web-based application, or maybe a simulator for a mobile app. I'm not too sure, but that stuff is quite complicated. I mean, what makes Pants maybe unique? Why would I want to use it, and why would it not be a good fit for me? That's a really big question to ask.
Yeah, I think one of the things that we feel differentiates Pants is that we have significantly less boilerplate than competing projects, and Bazel and Buck sort of count in that regard. We have what's known as dependency inference, where you do not need to declare per project dependencies or per file dependencies. And instead, we support extracting the dependencies from source files. So in most cases, the build metadata in Pants, which goes in capital B, UILD files, is effectively empty. And that means significantly less boilerplate for people getting started. And over time, it means that boilerplate doesn't go stale. So that's a critical difference. And it makes it easier to get started and easier to maintain.
Yeah, the differentiator you talked about for differentiation, right? You have the depends, you know, you have to declare
Dependency
all that.
inference.
Yeah, that sounds really useful because I can imagine if there's a flurry of updates from one part of the project but not on the other, that would be huge amount of
Yeah.
build time happening.
Yeah, absolutely. Yeah, it means that your dependencies are always completely accurate. And it's annoying having to repeat yourself, right? All of your import or use statements indicate what you are using, right? And in a monorepo in particular, they're unambiguous. You know which version of a particular thing you want. We have ways for accounting for multiple versions when you do need them, but the vast majority of the time, your import statements are unambiguous. I want this version of a library that's been declared within the monorepo. And so that keeping them always accurate means that your cache keys are always accurate, which means your tests hit the cache more often, compilation hits the cache more often, everything.
Okay. I know we did talk about, so there was a Pants version 1, 100% in Python. Version 2 means that there's a piece of it written in Rust, but still I think a majority is in Python. I think it's 70-30, right? 70% being Python.
Yeah, that's right.
Now,
Yeah.
did we actually touch on why things happen? I'm assuming it's performance.
Yeah, it was performance. As the 2.0 Pants 2 rewrite, we had designed a particular API for plugin authors that was really easy to use and is based on essentially having async rule functions, which can wait for additional work to have completed and are sandboxed. And writing larger and larger builds was spending more and more time in scheduling, and the scheduling code was implemented in Python. So the V2 engine, which is in Pants 2, is implemented in Rust. It uses Tokio, and the file system access is all async. The rule scheduling is all async, network access, cache invalidation. So sort of everything other than the plugin API itself, or the plugins themselves, I should say, is implemented in Rust. And we've been really happy with that change.
But why Rust? I mean, I see you already support Go, Java, and Scala. I remember the question she had sent to you. There's also some talk about Scala. You're from Twitter. I think Twitter's a huge user of Scala.
Mm-hmm.
Why take a look at going from a GC language to a non-GC language, and why Rust? Because Rust is, it's quite new, right?
Yeah, totally. Yeah, and it was. I mean, we started the experiments with Rust in about 2016, 2017 in Pants. And so Pants, at that point, I believe Rust was post 1.0, but just barely. But really, I think my experience with GC languages led me to believe that both that Rust would be about as easy to use as a GC language, but more performant and sort of more reliable in terms of its performance characteristics. The center of a build tool is a big concurrent graph, and a garbage collector is also going to work on a big concurrent graph. But we didn't necessarily want to sort of have the garbage collector collecting a graph of objects, which was also, a graph that we were trying to maintain with sort of utmost performance. And I think that's definitely played out well for us. I think some of the other potential choices for Rust, I wrote a document at the time, and some of the other potential choices were potentially to do it in C++, to use Go. And we felt that Python and Rust would make sort of a good pairing, both because Rust has a fantastic API, essentially API to Python. We use the Pyo3 crate, which has been great. Although we've gone through a few iterations, and Pyo3, I think, has matured a lot about the last year to make that true. But all along, sort of extending a language like Python with Rust has been a great fit.
Yeah, as I said, I think the Pyo3 is probably one of the best libraries for integrating Rust into other languages. Have you seen, there's a book by Lily Morrow. She was on our podcast before.
Oh, no, I haven't.
To talk about her book. Yeah, it's written on Manning, published by Manning. And actually, one of the chapters is actually using Python and Pyo3. So that's really cool. And there's multiple ways to use Pyo3 too, which is super interesting.
Yeah, it's a really fantastic library, and we owe a lot of thanks to the folks who work on it. I think before that, we sort of were using Python's facilities for C interop, and we saw so many null pointers and memory corruption issues at that point. It was still clearly the right choice to use Rust, because everything aside from the unsafe code at that boundary was bulletproof, and you had essentially no issues with it. So even before PyO3 existed, it was a great choice to use Rust. But PyO3, it definitely seals the deal of, okay, there's almost no unsafe code. And to the extent that PyO3 uses unsafe code, it's really bulletproof and trusted.
Yeah. Now, have you guys been in contact with the PyO3 team?
Yeah. I mean, certainly we've opened issues. They've been really accommodating. During initial port, at least to developers from that ecosystem, were able to help us out and showed up on our issue tracker to give advice about how to do things with best practices. So yeah, really great folks.
So for Pants 1 versus Pants 2, has there been a big feature changes, or is it really just about making a piece a bit more performant and efficient?
Yeah, between 1 and 2, it was challenging to write plugins for 1, both because the API sort of allowed you to do too much within some scope, where you could reach out and manipulate the file system and mutate things. And it gave you a little bit too much power in some areas. But in other areas, it prevented essentially self-recursion, right? So you couldn't generate code multiple times because the task graph was not fine-grained enough. Pants 2's task graph is much more fine-grained and allows for a lot more concurrency. So builds proceed, using as many cores as possible. All of the tasks are using the Tokio runtime and are able to proceed concurrently. All of the I/O and processes, in all of those interactions are also via Tokio, and that allows us to sort of maximize the parallelism that we can get out of a machine. So in terms of the end user API, a lot of this ends up showing up as the tool being more responsive, having a better user experience when you're building something large, because really we're all about building very large code bases as quickly as possible. And so having the tool, get out of your way as quickly as possible is important.
Now, has there been any issues that you found while integrating the two? I mean, because sometimes maybe PyO3 says that you can do these things, but then you found out it doesn't work for you, or actually doesn't work at all, or there's been lots of bugs for certain features when you integrate between Python and Rust.
No, PyO3 has been great. To the extent that we've had issues, like one example was wanting to add support for Python's DAP, debug adapter protocol implementation. There were intricacies of Python threading and the thread state attached to various threads that needed some finessing, but the PyO3 developers were really helpful in that. But certainly everything that's on the happy path and even fairly far off the path has worked. We've been very happy with it. Our biggest challenges with integrating Python and Rust are mostly just choosing appropriate API boundaries. We have a pretty good boundary as far as we are concerned between the plugin API and the Rust code that's sort of powering it. But if we wanted to push the needle from 30% Rust and 70% Python up to 50-50, we'd need to find a new cut point between the Rust and the Python. You can port sort of individual functions, but when you are providing like entire APIs with Rust, that's we sort of get the most benefit, because every time you dip back into Python, you actually have to acquire the GIL, the global interpreter lock. So the biggest challenge is essentially finding good boundaries where you can spend a lot of time without the GIL acquired and sort of let the CPU run unthrottled, essentially.
Yeah, that's the one thing I was kind of curious about is how do you figure out which pieces should be in Python, which ones should be in Rust? Because, I don't know, you may be so productive and in the mood that you keep kind of going on with Rust, and then you say, oh, crap, maybe this doesn't make sense because it's much easier, faster, or APIs may be better in Python. Because the one thing I know about Python is it's extremely easy to build CLIs. I was quite happy with that. I'm not a big fan of Python. I rather despise it. I think I said that quite a few times on this podcast. Maybe because the first big project I ever had was like I and my boss had different line spacing for tabs, the tab key.
Yeah.
And that was a horrible thing. But in any case, yeah, so that was kind of the start of my life in Python. And that was, it's like PTSD a little bit.
For sure.
But yeah, I mean, how do you divide between two? Where's the responsibilities usually lie for at least for this project?
Yeah. So I'll say the Python ecosystem has grown up quite a bit. And in particular, the creator of Python going off and spending a few years on adding type checking to the language was a huge boon. And, so the ecosystem has gotten quite a bit better in Python 3 now that it is sort of all the way out there, means that you have low latency type checking for your code base. And so that's certainly improved things. White space is still, potential pitfall. But as to how we choose API boundaries, the one we have right now is essentially that rule code, which is the bulk of plugin code, is written in Python as these async functions, but all file system access and dependency tracking is implemented in Rust. And I think in order to push the boundary further, we would probably need to support writing entire pluggable rule sets in Rust. As it stands, we can implement rules in Rust. But one of the things we've actually tried to avoid is this trap where we have tools that the community doesn't. And this is a bit of a thing in other large build tool ecosystems where essentially certain language backends are built in to the tool and are sort of the first among equals, right? They have tools that plugin developers don't, right? An example of this is in Bazel, and I know they've worked for a while on fixing this, and maybe they have, honestly, by this point. But the C++ rules in Bazel have superpowers that other plugins can't because they're implemented directly in sort of native code of Bazel, which is Java, right? So we do support implementing what we call intrinsic rules in Rust, but we don't want that to be necessary for a plugin to be developed. So it's a challenge. We're to sort of find the next large portion of the code base that we can rewrite in Rust. It essentially is going to mean finding a widely used plugin API that folks are unlikely to need to implement themselves, but that we can port and gain them performance benefit sort of transparently so they don't see.
Okay. Most of the questions that I had, and we had a good introduction about Pants. I think it's good to hear about, where is Pants going to be going in the immediate to far future? What's the future plans for Pants?
So we're always sort of fighting against the growth of your code base, right? We want Pants to work with larger and larger code bases with lower and lower latency. So we will continue to have performance work to do. As you mentioned at the beginning, we don't have Rust support. We would really like that because one of the reasons that people use a Monorepo build tool is also because they want to have polyglot setups in their repository. So for example, our use case, we don't currently dog food Pants for building Pants, but one of the use cases that you'd love to have is to be able to build both your Rust and your Python transparently so that when you make a change in your Rust code and then build your Python code, you get that same sort of Monorepo change detection across languages, right? And the same goes for any other sort of use case where you have a low-level language that a higher-level language depends on. So we'd love to support Rust, not just for that reason, but also because we love Rust. And it would be great to be able to use our own tool to bootstrap our Rust code.
Yeah, I would love to see Rust support. And I think this goes back to the beginning of the conversation about Go, where we found ourselves in the same situation of Go and Rust both already have really good tooling. So what is the value add? In addition to what Stu's talking about of facilitating work with multiple languages, I think some of the benefits we identified with Go and our users have been excited about with Pants' integration. One of them is the fine-grained caching that we've been talking about, that when you run your test, we know precisely which can be cached and when we need to reuse them. Whereas naively, Cargo, you rerun all of them unless you say -p, just run these. Another thing that we are excited about and our Go users is the benefits of remote caching and remote execution, that you can store those results of each test file in the cloud and you can also run them all in parallel. So you get way higher concurrency. And then another thing that a lot of people really enjoyed with monorepos is having a uniform interface. That Pants provides you an interface for things like you can run Pants FMT or Pants format for running all of your formatters, regardless of what language you're using. So if you have a bunch of Python, even shell scripts like S8 format and Cargo format, you can run Pants FMT : and Pants will do the right thing for all of your different ecosystems and all the different tools that you don't need to remember the differences between how to specify things. Same with running linters, running type checkers, compile checks, and running your test.
Yeah. We also mentioned at the beginning the Docker support, and I think that's kind of an interesting new development as well. We support in parallel building all of your Docker artifacts, and also we natively support cross-building now. So if you'd like to build to target a different platform from Mac OS, we will transparently within the build use Docker or remote execution to accomplish that. So when people have cross builds targeting different platforms or using libraries that they don't have installed locally, we can transparently in parallel, delegate that work outside of the tool. And that avoids, situations where you sort of have to like run your entire build in a container, even though there's just one, like a Docker container, even though there's just a small portion of it that actually needs to be containerized. And that sort of transparent cross-building is sort of a boon. Docker is, we want to use it the minimum amount of places we can, right? And that's what our fine-grained delegation to Docker allows for.
Awesome. I think the last thing I have to ask, is there any kind of shout outs or anything that the Pants team wants to give? Eric, yes, go ahead.
Yeah, my shout out is to the Pio3 team and David Hewitt and all the other contributors. So I originally came from a Python background and learned Rust while working on the Pants Build project. And I think that the integration, like we were talking about earlier, between Python and Rust is particularly powerful. I gave a talk in Spanish at PyCon about this, of when it makes sense to use Rust native extensions. And one of the main takeaways of the talk is that Python's awesome. It's very accessible. For a lot of teams, it's the right fit, but the performance is not always there. And Rust native extensions, especially thanks to Pio3, allow you to fairly easily, a lot more accessibly than it used to be with doing C and C++ extensions, allows you to get great performance during your critical path while still being able to use Python for the rest. One of the things that we've loved with Pio3 with our project is how well abstracted everything is, that to contribute to Pants, 95% of our contributors never need to learn Rust, although we find a lot are excited about it and want to. The Rust engine is abstracted away that you can dive into it when you want to and get low level, but you also can stick high level with Python.
Yeah, and we mentioned Tokyo, and I'm sure you get a lot of people thanking those folks for all their work on Tokyo, but that's been great. It's sort of the bedrock that we're built on. We also use, the indicative library for our UI. We use PetGraph, which I think came out of the Rust compiler and has been super helpful for grappling with very large, million node graphs for invalidation. I mean, we use things like Tonic for our remote execution support to do gRPC. So we have used, I guess, something like 450 transitive crates. So we have a lot of folks to thank for the ecosystem.
Yeah, you're using all the good libraries. I can recognize a lot of those names, and I don't even do very much Rust.
The last thing I think also is all the people who are out there making Rust more accessible for learning. In college, I really did not like my operating systems class, which was in C, and very masochist and just too low level, and systems programming was never something that I would get into and enjoy. Here I am doing a lot of low level stuff with the Pants project and finding that I love it. I think a big reason for that is how much more accessible Rust is, and that you don't have to try to keep all of these low level things in your head, like whether a pointer is still valid or not. I was a little intimidated getting into Rust, and I think the resources like the Rust book, and including a lot of the more advanced resources out there now, like John's Rust for Rustacean's book, have been incredibly helpful for me. Same with the Crust for Rust videos, super helpful for me learning something that I didn't think I'd be able to learn.
Yeah, I also recommend John's channel. It's really good. Like you said, the Crust for Rust is it called Crust for Rust? It's called Crust of Rust, I think. I don't remember. Something with crust and Rust. That's all I know.
Yeah.
Yeah, and I remember I asked him about it, and he was like, "Yeah, it's kind of like the outside of Rust that people don't really deal with, or something. That's why it's called Crust of Rust." Yeah, every time I think about it, it reminds me of pizza because of the crust of the pizza. I don't know. But yeah, that's a great series. John's got awesome video content. He's still producing nowadays too, and his book is. I tried reading his book. It's really difficult for me to read. I don't know if I feel like I need to spend a lot more time. Maybe I need to take a master's degree to read it because it's very. It's just stuff I never learned before, and there's a lot of like stuff that is he talks about that is very theoretical, which I like, but it's like, oh man, I don't quite get this. And sometimes I have to read it 3-4 times and then I start to get it. And along with doing some more research. And
yeah.
Don't you feel that after you graduate, you do more studying than when you did when you're in actual university? It's really crazy.
Yeah, for sure. That's been one of the good things that I've enjoyed seeing with the Rust community is the diversity of resources. Before my current job at Toolchain, in between working at Twitter, I was a middle school computer science teacher teaching Intro to Python. And we talk about with teaching how important it is that people learn different ways. Some people like videos, some people like books. So I love seeing, especially in the past few years, how many different new resources have been there. And one of the cool things I want to give a shout out to is also that there's a lot of resources now in Spanish. Including, I think, a class from Microsoft that I live here in Mexico City, and it makes a really big difference having native language and native resources for people.
Absolutely.
Yeah.
One of the things about having a very accessible language that's also so low levels is it's just, you can sort of exist at a whole bunch of different stratas within the ecosystem and be very happy, right? If you're writing extremely low level code, you will have a good time. If you're writing relatively high level code, you will also have a good time. Right, because the ecosystem is sort of supporting that and allowing for all of these use cases in harmony. So,
yeah, actually, on that note, the episode on Axum from Rustacean Station last month inspired me to do a little mini personal project with it. I didn't think that I would like doing web development in Rust, but I had a great experience with it.
That's awesome to hear. I still feel that Rust is a little bit immature compared to other ones. Like Python's got great web support, but that doesn't mean it's not going to be good someday. It just needs more time to mature, right? We still have the Lego pieces. We're still building everything. But yeah, Axum is doing great. Okay, I think we need to wrap up.
My daughter just started breaking down. So yeah, that clock has run out as well.
That's the alarm, right?
Yeah, that's exactly.
The bell.
My wife did an amazing job disappearing her for an hour. Yeah,
definitely. Okay.
Thanks a lot, Alan.
Cool. Thank you all for attending.